Hi all, we're starting our chapter 12 in Algebra 2. It is a chapter on trigonometry. So the unit is going to cover some sections, 4 sections to be assessed on. The sections will be assessed on are 12.1, 12.2, 12.3, and 12.5. And radians, which belong, I think, to 13.1, but I don't know. So we're going to have 3 quizzes till the end of the year. And those 3 quizzes are quiz 1, quiz 2, quiz 3, big quiz 3. And page 19 gives you an example of what your first quiz is. And page 21 will give you your second example. So quiz number 1 will be a memorization quiz to get 6 out of 6. Quiz number 2, another memorization quiz. I believe it's out of 15 or 18. And then the bigger quiz, which is out of about 60 points, will encompass everything, not really memorization. So if we have time, I usually bring the students into some extension ideas about trigonometry, which may or may not be on the final, but it will not be quizzed on. So let me show you your quizzes, what they will look like. So on page 19, there's something in the book. I'll tell you the page when we get to it. And this chart is in the book, and you'll be asked to memorize this chart, and it's worth a 6-point quiz. And as you can see, it's just the same quiz. I'll probably just print this page out, and you'll get a 1/3 of a point for every answer. It's in the book. It's very easy to memorize. When you're done with that, we have a unit circle quiz. By the way, if you look on page 20, it's the same quiz for practice. Then we'll have a unit circle quiz. This was the year 2015, 2016 that I gave that quiz on the unit circle, so I'll have something like that. And then that's a 12-point quiz. And then once you have all that memorized, it'll give you the opportunity to be better at the future things that we do. It's always nice to read a little bit of history about trigonometry, and we always focus in on some mathematicians. I don't wish to butcher the name, but it looks like Aryabhata the Elder, who talked a lot about the sine function and named the sine function. And something about the tangent function comes from, it must be Latin. It actually sounds Italian, because the word in Italian for shade is umbra. But this is umbra versa, which means turned shadow. So you can read the historical part on your own. Okay, so let's start in on taking notes on 12.1. Oh, I guess I don't have an objective for 12.1. I'm totally blanking on that. So before we take our notes on 12.1, I want to show you some symbols that get used in trigonometry. So when I refer to a certain angle measure, and I'll call the first time we look at one, we call it theta. It's just a Greek letter. It looks like a cursive O. Theta is cursive O. It's the first of them that are usually used. And then if I'm talking about another angle I'm referring to, the next default, so that's your default one. The next one is alpha. Beta is used also, like this, a capital B-ish. And then phi is used. It's like a 0 with a line through it. So I'm just going to say theta, alpha, beta, but I'm not going to write theta for theta. So there happens to be a little bit of vocabulary going on this section, so I pre-wrote it while I talked about it. So trigonometry, the actual word trigonometry means triangle measurement. Just to let you know, I don't have to write this down, but like it's used, trigonometry is used in a lot of different fields. You guys have done SOHCAHTOA before, and you know a surveyor needs SOHCAHTOA, a bridge builder needs SOHCAHTOA, and so on and so forth. Now, on each of these, you'll get a picture of what I want, but I needed to fit in this picture, and it's not a picture of trigonometry. This is just a picture of the coordinate plane. So you're not going to use the coordinate plane in a method that you're used to usually seeing it. Remember, this is not a picture of trigonometry. So when you're looking at the coordinate plane, you do have to remember you're in quadrant 1, you're in quadrant 2, you're in quadrant 3, and you're in quadrant 4. So that's awesome prerequisite knowledge. So this quadrant is a positive ordered pair, negative positive ordered pair, negative negative, and positive negative. And again, you're not using it in the same way that you think, where I'm looking at the ordered pair 5, 6. That's not the way trigonometry works, but we'll get to that at another time. Okay, so the next word to know is the word degree. So the degree is a label that we use to measure an angle. So, and then the other word I'm going to add is radian. It's also a measure. And when we measure in radians, this is measured in pi values. Well, degrees are labeled in this little degree symbol. And just to let you know, and I'll show you this on the next page, 1 degree is equal to 1 over 360 if, I'm sorry to squeeze this in, of a revolution. So if you can't see it, it says 1 degree equals 1/360th of a revolution. So write this definition down first, and then we'll talk in just a second, because this initial side, terminal side, is one of like this really important pieces of it to understand something. So what you do, what an initial side, terminal side means is you generate an angle. I'm going to show you in a second how you generate an angle. You can generate any angle. Again, the first one we tend to use as the letters theta, our default symbol. So you can generate any angle theta using what's called a rotation. And a rotation that moves one of the rays, and I'll show you the rays, from the angle from its initial side to its terminal side. These are called directed angles. So let me show you how this works. So you're going to kind of go counterintuitive of your life. You're thinking, usually you think of when you go to the right, you go positive, and to the left, you go negative, but we're going a little bit of counterintuitive. So this one right here is called our initial angle. Our initial side, sorry, not our initial angle. That is a different word. So that's your initial side. And then we travel to the terminal side. So let's say I go I'm traveling to the terminal side. You have to show the direction that you're traveling. Yes, you could have traveled this way. That's fine. But this is the way I'm traveling because I picked the way to say it. So that's your initial side. Where did I put that word? Right here. And then I'm going to travel on over to my terminal side, which will be this right over here. I've traveled to my terminal side. I have to put an arrow to show the way I traveled. If I traveled the other way, the arrow would go the other way. So just to let you know, this particular angle is theta. We say theta equals, and then you usually assign a number to it. So you don't know what the number is to this. So in this one, you just said, I traveled in a positive direction. So the angle is positive. Now, there's a word that's going to be positive and negative are going to go counterintuitive. I'm going to write this down. Counterintuitive. Like against your, I know I spelled that wrong, but it's against your intuition. So when you go to the left, you're like, isn't that a negative? Nope. In this case, you're going to go counterclockwise. So positive is counterclockwise. Now, if I was going to go in the negative direction to my terminal side, and I was going to go this way, I know that that theta is equal to a negative number. I don't know what it is because I don't know how far I traveled. But I did go clockwise like a clock travels with the hands, and I went to my terminal side. So another thing is I'm just going to see, I color-coded the initial side right here. See the color code in the orange? So right here, if you can see it. So this was my initial side. And I traveled to my terminal side. This is very boring stuff, but you got to get the vocab down. So this is my initial side. And I traveled to my terminal side. And I will be doing that a lot but you got to put the arrow because this is not enough. So I'll have a coordinate plane and you'll say, oh, I went that much. But you have to show me, there's a big difference between going this way and going that way. Those are two different angles. That one's a positive angle. So that one's positive, maybe 50 degrees. And this one is negative, maybe 50 degrees. I don't know what it is yet because I don't have a measurement yet. But you have to have those directed angles. So you kind of see these ones float in around like, hey, where did you start that one? There's no coordinate plane. So a lot of times you need a coordinate looking plane, literally just two axes, to help you figure out the standard position. And I gave you a lot of examples of a standard position on the next page. So I'll show you in just a second. But an angle whose initial side coincides with the positive axis, there's that word initial side again. So if it starts here, 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 then we're talking it's a standard angle. If it starts somewhere else, it's not standard. We like to deal in standard angles, and sometimes we don't, but we'll talk about that at another time. So let's say I decided to travel in my directed angle going this way, and I put the arrow and I stop here. So what you do is you then put your arrow there. You say, hey, that's how much I traveled. So again, not a lot of people will know this. You can't be exact on this one about what the theta is equal to, but I got to tell you, I know my theta is a positive angle. And there is actually another thing that I know about theta in that position, and I draw this again when I move down the page. 0 degrees starts right here. And since this is a right angle, this means I traveled 90 degrees. And then if I travel a little more, this would mean I traveled to 180 degrees. So if I stop right there, I know my theta is positive, but I know it's somewhere between 90 to 180, but I'm not sure how far in I went. And you can't estimate. You could just say it's between 90 and 80. So on this one, but I also know my quadrants, quadrant 1 and quadrant 2. So you actually say it ends in quadrant 2. It ends in the second quadrant. So you'd actually say, if someone asked you to draw one in the second quadrant, you'd show that it ends in the second quadrant. So it means, angle, when it ends in the second quadrant, we say the angle is in the second quadrant. Okay, so notice this one over here is, I'm going to take a trip around, and around, and now I stop over here. That still is a positive theta. So theta is in the third quadrant. I still know it's positive. So again, as long as it starts there and ends somewhere, it's called a standard angle. So if I went the other way, I just happen to draw another one. I'll go this way. And now I'm going to go this way with it and say I want to end it here. I still ended it in the first quadrant, but my theta is negative. Because it doesn't matter where the quadrant is, I end when I say it's positive or negative, but I do say angle is in quadrant 1. So the angle here is in quadrant 1, but because the terminal side is in quadrant 1. It happens to be a negative theta though. So I hope that helps you to understand that an angle whose initial side coincides with the positive x-axis is a standard position angle. So a lot of times you don't know what that one is, but if it ends, that measurement is. But if the terminal side ends on one of these axes, then you've got something called a quadrantal. A quadrantal is a very important word. People don't give it enough credit, let me tell you. So a quadrantal means it starts in standard over here, and it might end, I don't know, say over here. And I can say a lot more than it is positive. I can say even more. I could say it's 270 degrees. I'm pretty positive that's 270 degrees because this starts at 0. If it ended here, it'd be 90. If it ended here, it'd be 180. But it ends here and it's 270. And then, of course, this is a 360. And then 360 plus 90 is 450, and so on and so forth. You could keep going around, but we'll talk about how it goes around and around. So if a teacher's saying you have a quadrantal angle, it ends on one of the axes. That's a very, very important word. So there's your angle. And just because you see your angle like this doesn't mean that's a right angle. There's no such thing as a right angle anymore because an angle is directed. If I went like this with it, this would be theta equals 270. If I went this way with this, this would be theta equals negative 90 degrees. So it depends. You got to look at the arrow. And then the last word is the word coterminal angle. Coterminal angle. So with a coterminal angle, let me see if I got everything down over here. I'm going to draw a couple more of the coterminal angles. So two standard position angles. So coterminal means two. So you could, the way you would draw it, you'd show, you probably show two on the different ones. It'd be nicer if they have them side by side. So if I say I'm going to have this go to 150, and I'm making it up, and you're like, where'd you get 150? I'm telling you it's 150. A lot of times teachers will say it's 150. So if it's 150, you better know to draw it there because it goes past the 90. But two standard position angles whose terminal sides coincide. There's a formula for it. So say I want another one in the exact same position. So the way I'd get it is I'd do 150 plus 360 to get to that. But it's a little bit more than that because how many times do you want to add 360? Add it over and over and over and over. How many 360s do you want? So what the formula for it would be, you take your theta and you either add or you subtract n times 360. It depends how many times you go around. So over here, say I want to go around twice. So I'm starting in my standard. I hit 150. I don't stop. Watch how I do it again. I go around and then I pass it again. See how I'm passing it? And I denote it by going up to it once again, just like I went up to it over here, but I drew an extra circle. So that 150 plus 360 adds up to 410. I think it's 510. I'm not doing, it's hard to do the arithmetic in your head when you're talking. So those are two terminal angles to each other. If I wanted to do two other coterminal angles and say, I want a 100-degree angle, I'm always stopping in this quadrant because it's an easy quadrant to give you a visual of. So let's say I'm not going to do theta this time. Let's say I'm going to do alpha. So alpha is equal to 100 degrees. And let's say I want a coterminal angle in the other direction. So that one's counterclockwise at 100. But if I go this way and I reach up to that, now I have to name that alpha to be, I think this one is negative 260. So let me show you how I got that negative 260 arithmetically. So the negative 260 was gotten by doing theta, which is 100, minus the n times 360. But in this case, the n was 1. So it's 100 minus 360. So therefore, it was a negative 260. See how that works? So these two are coterminal angles. One was positive, one was negative. So it doesn't matter how many times you go around. It's just whatever one is asked for. So I could go around many times, like I'm going to give you another coterminal to this one. Another coterminal. So these are all going to be coterminal to each other. So I want it to end here. So maybe I'll go, and I won't stop at it. I'll go around, and then I'll go around. How many times am I going to go around? I think I'm going to go around one more time, like this. So then you say your alpha is equal to theta plus or minus n times 360. So this one's going to be a plus. So your theta is 100 plus 2 times around times 360. So 100 plus 720. This would be an 820 for you right there. So that's 820. And I have some extra examples too. These are more just vocab more than anything, but I do definitely have some extra things that I'm going to talk about. So if you turn the page, you know how I said I'm going to talk about a standard position on the next page. So let's look at the next page, and there's nothing for you to do on this page. Just read it. Just read it. So an angle is in standard position when it is its initial side. What color did we use for initial side? I think we used our orange, and our terminal was yellow. So we might as well keep with the. So that's the initial. That's the initial, and there's your initial side. Notice how the terminal ended over here in quadrant 2. The terminal ended in quadrant 1, and on this one, 270, it ended at a quadrantal. So it wasn't in a certain quadrant. So as shown in the diagrams below, angles in standard position can be classified according to the quadrant in which their terminal side lies. If the terminal side lies on a coordinate axis, it's a quadrantal. The terminal side lies in quadrant 2, so we call it a second quadrant angle. The terminal side lies in quadrant 1, we call it a first quadrant angle. Even if we're going in a negative direction by 300. So over here, this one ends on an axis, so we call it a quadrantal. Very important ideas about standard. And then here's our idea about coterminal. Two angles in standard positions are coterminal if their terminal sides coincide. So you see this one, ends, all ends in the same position. And so that initial one is 150. So that's 150 times 0 times around. 150 plus 360 around, giving me 510. 150 plus 2 times around, giving me 870. 150, but goes around in the negative direction, times 360. Therefore, it's negative 210. So this just represents what I did on that first page. Okay, so the last of your notes are on this page. It's more on coterminal angles with us doing the coterminal angles. So we're going to write a formula for the measure of all angles coterminal with the following angles. Then we're going to use the formula to find 2 positives and 2 negatives. There's an infinite number of answers to this one. But if I say, okay, I got my 30-degree angle. I don't know exactly where it ends, but that looks like it's 30 degrees right over there in that direction like that. That looks 30, like we say theta equals 30. As long as it's in that first quadrant. Remember, we're going to use theta plus or minus n times 360. So let's say I wanted a positive one. If I wanted a positive one, I'd do 30 plus, pick your n value, times 360. I don't care what we use. Say we use 7. So we get to our calc and we do 30 plus 0, 2, 4. Is it 2520? So therefore, that's 2550 degrees. So if I were to draw that one, it would be really sloppy. It would look like this. 1, 2, 3, 4, 5, 6, 7. I think I might have gone 8. And there it is. That's your coterminal positive. It's just important to say it is not the same angle. It is not the same angle. You heard me say it, it's not the same angle. I think there was one more thing I was going to tell you. And that one was, that positive one was going counterclockwise. And notice I went counterclockwise on this one, which is your positive direction. Now let's say I wanted to do a negative one. If I wanted to do a negative one, I would do 30 minus, let's say we wanted it to go around 2 times 360. So it's 30 minus 720, which is negative 690 degrees, which is the clockwise way. So if I were to draw this one like this, I would, to get to the 30 like this, I'd go around 1 and then 2 around, I think I went, or do I have to go 1 more? So you go around 1, 2, and I think it's 1 more, but I forgot. There you go. So if you wanted to do this with 70, you do the same thing. Say 70 plus 10 times 360, and that gives you 70 plus 3. I've just made up a number, 3670. And if you wanted to do a negative one, this would be, you could just do minus 360, and you get negative 290 degrees. So that's how you'll do that one on your homework. It's really not that hard. Okay, so one more thing now. So now we have, I'm telling you that the measure we always measure in until I teach you radians is going to be in degrees. And as you know, the degree symbol is like that, like 30 degrees, 40 degrees, things like that. So if something isn't exactly a degree, what do you call it? What if something's not exactly 40 degrees and it's not exactly 41 degrees? You could call it 40.5 degrees. That's fine. However, in between, you can actually call it 40 degrees something minutes. Actually, it's called minutes, and something seconds. So that's the symbol for seconds. That's the symbol for minutes. It's sort of like saying you found something to be 10 meters, like 12 meters and 2 centimeters, right? You can say 12.2, or you could say 12 meters, 2 centimeters. So this is breaking down your degrees into something smaller. Here's what I mean by that too. So let me show you what a teeny, teeny, tiny degree is. So let's just say that's 0 to 90. And this is your little 1 degree measure right there. This, I actually made it bigger for your eyes to see. So that's 1 degree. So if we fill in that whole 1 degree right here, and I wanted to take a little bitty part of that 1 degree like this, I would probably be measuring that little degrees in minutes or in seconds. So let me show you how the conversion works. So with the conversion, this is kind of the definition part of the conversion. 1 minute is written like this, 1 minute, and it's really 1/60th of 1 degree. And if you want to get even smaller than a minute, so see that little thing right there? That little 1 minute is 1/60th. But if you want to get even smaller, you say 1 second, which you write like this, 1 second, and that's actually 1/60th of 1 minute. So so a second would be 1/60th of 1/60th of a degree. So let's do that. So let's convert. Then I'm going to show you how you convert on your calculator if I can find my notes on that. So I have, this one's 14 degrees. And this is 36 minutes. And this is 54 seconds. So this is a measure that's somewhere between 14 and 15 degrees. So I'm going to convert it to decimal, and then I'm going to go the other way. See, that's converting it to decimal, and this is converting the other way. So how do I do it? So I take my 14 degrees, and if you're going to make it into a decimal, you already know it's 14 point something, right? Because I'm at 14 degrees. So let's start with the answer is 14 point something. So you say I'm going to take 14 plus whatever 36 minutes is, plus whatever 54 seconds is. So 36 minutes is 36 out of 60 as far as a degree goes. So it's 36 out of 60 degrees. And then this one is going to be 54 out of 60 times 60, which I'd rather write as 3,600. So you've got to take your calc out right now. Take out your calc. And even, by the way, you can use your graphing calc on this whole unit except for the memorization quizzes. So this would be 14 degrees plus something plus something. So do that on your calc. What is 36 divided by 60? And it should give you 0.6. So this is a 0.6 right here. And remember, that's 0.6 of a degree. So this right here, when you do 54 divided by 3,600, you'd get 0.015. When you add those all together, you get your answer of 14.615 and then label it degrees. So now let's say you want to go backwards. So if you want to go backwards, what you do, and then I'm going to show you how to do this on the calc, but again, I got to find it on the calc, how to do it. So when I want to do the 72 degrees, I know I'm going to have 72 like this degrees, and it's going to be, so the answer, sorry, is going to look like this. 72 degrees, something minutes, and something seconds. So the 72's for sure. So we take this 0.568 and we multiply it by 60. And if we get a nice whole number, like if it said just 34, then I could put the 34 over here, and that would be hunky-dory. But it's really 34.08. So that's just a little bit left over seconds, but there's your 34 minutes. And then the 0.8 is going to go here by multiplying 0.8 times 60, which gives me 4.8. We don't break that down anymore. We just write 4.8 seconds. So on the calc, the way we do this is, someone showed me this, a student showed me this, so let me just make sure I get it right and look at my notes correctly. So if you want to do it on your calc, you can zoom in right now, and you're going to do, I'm going to write it like this. So you're going to take the, I don't memorize this, so I'd have to try it on my calc too. I'm going to do the word, I'm going to put 14 in my calc, and then student told me to write second, not right, but go to second apps, and then go to the number 1, and then push enter. Then you have to still put in 36, and then you're going to do second apps 2. I don't think you enter, so check that out. Then you're going to go to the 54. Maybe you do enter. Maybe it is enter. And then you do the 54, and you do alpha plus enter. But I will hear other words if I did it wrong, just let me know. So if you ever want to do this in your calculator as a conversion, this seems to be the graphing calculator conversion. So there's a lot of drawing of this on your homework. So my first year, I let a lot of kids draw this. So instead, I did a template to save you some time. So your homework is in the book on pages 552. This is section 12.1. 552 to 553, 1 through 45 odd. So here's how I'm going to ask you to do it. So it's very nice when you upload your work. This is going to be number 1. This is going to be where you do number 3, because you need 2 axes for number 1. Then you need 2 for number 3. You need 1 for 5, 1 for 7, 1 for 9, 1 for 11. As you can see, 13, 15, 17, 19, you need all of these. And then what's really weird is I put too many near number 1. So this is where you're going to do 21. So it's no big deal. You're going to put 21 up there. And then as you can see, you'll turn the page. So 19, 21. And then you'll get to 23B right here. 25B, 27B. Like, I don't know why there's 27A. I don't know where that is. I'm sure it'll be self-explanatory. 29B. 31, 33, 35, 37, 39, 41. 31, 33, yep. And then 43 and 45, and then you're done. And then you take a picture of that also. So I will upload exactly what it is that I want you to do and when it's due, and I will write it down on your Google Classroom. Okay, have a great day. Bye-bye.